Hello students and welcome to my channel. My name is Mr. Mesha Ngige and welcome to eMaths with Ngige. And today we're going to be checking a very simple topic requested by some of us, that is a 2x2 matrices. And basically by the end of the day, we're going to have learned, by the end of this lesson we shall have learned everything that pertains that 2x2 matrix. So this is one full lesson that will cover from operation of matrices and also solving simultaneous equation using matrices. So kindly remember to subscribe, share, and also comment how these lessons are being helpful to you. Now we shall jump right in by just defining matrix. So a matrix, we'll say, basically is just an arrangement, an array. And say a matrix is an array of elements in something we call rows and columns. All right, so this is basically an arrangement of elements in terms of rows and column. Then by the end of the day, they're just what? They're just bracketed. So for instance, IA. So in essence, if you have A and we say we have A, B, C, and D, then the elements that have been arranged horizontally are called these and these. So this element and this element AB, and you have C and D, then these ones are called rows. Okay, so elements arranged horizontally are called rows. Then you have elements that have been arranged vertically are called columns. So they are called columns together. So basically, by the end of the day, what we shall be dealing with are rows and columns together. So we have that, and this is what we shall be working with. So basically, any operation that shall involve a matrix, and they are to be specifically 2x2, but some just cut across all the matrices, either 2x2 or 3x3. But the concept is just the same. All right. Now, so since we know these ones are rows, these ones are column, we can just check something called the order. So we say the order of a matrix is given in terms of what? Is given in terms of row and column. So the first number when you're talking about a matrix will be the row, and the second number will be the what? Will be the column. So for instance, we have A. Then let's say A, B, C, D. We talk another matrix. Let's say 4, 2, 3, 1, 4, 6. Then you can have a last one, which you can say C is given by A, B, C, D, E, and F. So by the end of the day, this just comes. We're talking about the order of these matrices here. So these are three different matrices of different order. So let's see, how do we name them? So we say elements arranged vertically are called columns, and the ones horizontally are called what? Are called rows. But remember, we start with the rows, then we go to the what? We go to the column. So let's see with A. So you can get the order of A. So A, matrix A is given by. So how many rows do we have? 1, 2. So it has 2 rows. How many columns going down? 1, 2. All together. So this one is a 2. Then you say by 2. So the cross there just indicates by. So it is a 2x2 matrix. Let's go to B. So B will be given by how many rows do we have? 1, 2, 3. Okay. So we have 3. How many columns? These are elements arranged vertically. So 1, 2. Okay. So it is 3 by 3 by 2. Then lastly we have 1, 2, 3. So this is C. It has we shall start with the rows. So we have 1, 2. Okay, so it will be a 2 by, then you go to the columns, 1, 2, then you have 3. So it is a 2 by 3 matrix. So basically that's how naming of matrices happens. Now, having known this, then we can just dive in and or I can just give some few definitions. We have a matrix called a row matrix. A row matrix is a matrix with only one row. It has one row, but it can have a few columns. Then we have the column matrix. A column matrix is a matrix with only one column, but it can have how many rows? It can have a number of rows, but it is only one column. Then you have another matrix called a zero matrix. So a zero matrix is a matrix with all elements inside that matrix being zero. Okay, so that is it's called a null matrix or a zero matrix. Then another very important matrix that you need to know is the identity matrix. In this one, I'll need to write it. Identity matrix. Sometimes it is also defined as the unit matrix. Unit matrix. Unit matrix. So a unit matrix given by I, so it is named as I, is just written as, in a 2 by 2 to be precise, it will be the matrix where the main diagonal, this diagonal here, are all ones, alright? Then all the other elements zeros. Okay, yes. So this one is called an identity matrix. So the main diagonal numbers are ones, then the other diagonal, that is the minor diagonal numbers, are all what? Are all zeros. So we have these for a 2 by 2 matrix. Remember, an identity matrix is only given in something called a square matrix. A square matrix, by definition, is a matrix with the same number of rows and the same number of elements. Right together, a square. From the word square, we know a square is a figure, a plain figure that has two sides first of all, and what we say is all the sides are the same. Okay, so the length and the width, they share the same measurement. So therefore, when you say about a square matrix, we are saying therefore it is a matrix with the same number of row and column. So if you say a 2 by 2, that one is a square matrix because it has how many rows? It has 2 rows and it also has two columns. If we say a matrix is a 3 by 3, then we're also saying it has how many rows? It has 3 rows, it has 3, and it has 3 columns. So that one is called a zero matrix. So these are very important matrix here because we shall be using it, the identity matrix. So you have to note it down somewhere because we shall be having a few applications that shall apply this together. So now from there we can check the operation of matrices, and we shall start with a very simple, that is addition and subtraction of matrices. So let's check operation of matrices. Operation of matrices. So we'll start with one, addition and subtraction. Addition and subtraction. Alright. So we have addition and subtraction. So on this one we say, given a matrix A, so we can have given a matrix A is given by A, B, C, D, and B, the matrix B given by B, C, D, E, F, G, H. Then A plus B should be given by A, B, C, D plus E, F, G, H. Now in this case we know that elements occupying the same position in the matrix shall be added and subtracted. Are we together? So A shall be added to E, B shall be added to F, and so on and so forth. So therefore we have A plus E, and we have B plus F, and we have C plus G, and we have D plus H. So that shall be your addition. Right together. Then A minus B shall be given by A, B, C, D minus E, F, G, H. Therefore we are saying elements in the same position again subtract each other. So this will subtract this. So A minus E, then we have B minus F, then we have C minus G, then we have D minus what? Minus H. So that will give you the subtraction of A, subtract B, and this one will give you A plus B. So you can check an example or two to illustrate this. So you can have an example. So you can say if A is given by 2, 3, 4, 1, and B is given by 6, 2, 1, 4. You can just have that. Determine A plus B is the first one. You can have 2. You can have B minus A. So the same process applies. So we are saying that if you have elements, so these are 2 by 2, is a 2 by 2. Remember again, matrices can only be added and subtracted if they are of the same order. So a 2 by 2 matrix can only be added to a 2 by 2 matrix. A 2 by 1 matrix can only be added to a 2 by 1 matrix. So therefore A plus B. So A plus B shall be given by, so you have your matrix 2, 3, 4, 1, then plus B is 6, 2, 1, 4. So again, the matrix that the elements in the same position shall be added and subtracted. So we have 2 plus 6 shall give us what? 8. 3 plus 2 shall give us 5. 4 plus 1 shall give us 5. And 1 plus 4 shall give us also what? Shall give us 5. So at the end of the day, that gives you A plus what? A plus B. Now we come to the next. We have B minus A. So we have our matrix B, 6, 2, 1, 4. Then you have our matrix A, which is 2, 3, 4, 1. All right. Again, the same procedure applies. Subtract elements in the same position. So 6 minus 2 shall give us 4. 2 minus 3 shall give us negative 1. 1 minus 4 shall give us negative 3. And 4 minus 1 shall give us what? Shall give us 3. So therefore, when you add and subtract those two different matrices, these are the solutions. So that is it for addition and subtraction of matrices. Now let us jump into multiplication of 2 by 2 matrix. And in this one, we're going to start by scalar multiplication. Then we shall check now the general multiplication procedure. All right. So you can get as many examples as you can and try them out right together. So that was the first one. When you come to the second, that is multiplication. And we shall start with the first one, which says the scalar multiplication. So by the end of the day, when you are handling scalar multiplication, it means a scalar is just a number. So a scalar is any number. By the end of the day. So you can say if our A is given by generally again A, B, C, and D. And let me use a very Greek letter, that is a lambda. I shall use this. So and lambda is a constant. Okay, and lambda is a constant. Then we know one thing, that lambda A will be written as lambda, which is a constant, then the matrix A, B, C, and what? A, B, C, and D. Now this constant here will multiply every element inside the matrix. So the result for this shall be given as lambda A, lambda B, lambda C, lambda D. So this is the outcome of a scalar multiplication. So therefore, anytime you have a constant outside the matrix and you're multiplying it to the matrix, then that constant will multiply each and every element inside the what? Inside the matrix. So for example, i.e., let's say A is given by 3, 4, negative 1, 2. And so we have that. Let's just use this one matrix. So A is given by this. So determine, just told to determine 3A. Okay, so you're told to determine 3A. So therefore, 3A, we are saying therefore this one is a constant, this one is a matrix. Are we together? So therefore this shall be written as 3. So let's just write the solution. The solution here. So 3A shall be written as 3 multiplied by the matrix A, which is 3, 4, negative 1 and what? Negative 1 and 2, which by the end of the day shall give us. So these 3 will multiply every element. So 3 times 3 gives us what? Gives us 9. 3 times 4 gives us 12. 3 times negative 1 gives us negative 3. And 3 times 2 gives us what? 6. So by the end of the day, when you're talking about scalar multiplication is, when you multiply a number times a matrix, the number multiplies each and every element inside a what? Inside the matrix. So generally, that's how you do scalar multiplication. So now, having known how to do this, so it is as direct as that and as simple as that. Now, having known how to do scalar multiplication, now let's check how do you multiply matrices in general. Okay, how do you multiply matrices in general? Now, therefore, so that was scalar multiplication. Now we check general multiplication. So if a general matrix A is given by A, B, C, D, and B will be given by E, F, G, H. So remember, I'm just using general terms because matrices, the variables or the elements inside vary. So I'm just using a general term. Then we say then A cross B, or A multiplied by B, sometimes it can be written as AB, which means the A has been multiplied with B, shall be given by A, B, C, D multiplied by E, F, G, H. Or I can just let me just arrange it in terms of the multiple sign between them. Sorry, E, F, G, H. Now, in the multiplication of a 2 by 2 matrix, we say elements are multiplied in the form row column as they are being added together. So the first row will multiply, the first row elements will multiply the first column elements in the second matrix. Again, the first row again will multiply the second column. So therefore, the solution for this will be A, so I'll just write dot E to illustrate multiplication. So this element will multiply this, the first and the first, the second and the second. But you can note, I'm multiplying the row multiplied by the what? By the column. So it is AE, then BG. So plus BG. When you come to the next, A times F, it is AF. You can just put dot or AF, so it's alright, one and same thing, plus B what? BH. So it is row, column, row, column, row, column. See, then you come to the second row. So the second row again multiplies the first column and the second column. So you can see every row multiplies both columns on the other side, right, together. So it is AB multiplied by EG, then AB again multiplied by FH. Then you come to the second row, again the same procedure takes place. So C times E, which gives us CE, then D times G plus DG. Now remember, you can see what you're doing. We are doing what? We are doing addition between the terms. Then you have C times F, we have CF, then plus D times H, we have DH. And that will be the result of any 2 by 2 matrix multiplication, right, together. So that is it. Something to note when it comes to multiplication, elements in terms of multiplication do not necessarily have to be of the same order. But there is something called a compatibility test. I can just have it here. Compatibility. So the compatibility test says a matrix can only be multiplied, two matrices can only be multiplied together if the order of the column of the first matrix is the same as the order of the row of the second matrix. So I'm saying if a matrix A is given by 2 multiplied by 1, that is a 2 by 1. Then B is a 1 by 2. Then these two matrices can be multiplied together if and only if 2 multiplied by 1. So if I have to multiply them together, then this one is a 1 by 2. If these two center numbers are the same, then we say those two matrices are compatible, because the column of the first matrix is the same as the row of the second matrix. So you can see we have a 1 here and we have a 1. Okay. Then the numbers that remain outside, that is the column and the row and the column, form the matrix that we shall have. So the resulting matrix, when you multiply a 2 by 1 and a 2 and a 1 by 2 matrix, shall be a 2 by 2 matrix. Together. So these two numbers are the resulting matrix. Is the resulting matrix. Then these two numbers here illustrate that the two of them are compatible. So we can see if they were not the same. So if I had another matrix C and it is a 2 by 2. So if I'm to multiply AC, I shall have, it is A is a 2 by 1 and C is a 2 by 2. So you can already see that the middle terms are not the same. The middle, the row and the column are not the same, because one is 1, this one is 2. So we can say the two are not what? Compatible. But what about CA? C is a 2 by 2 and we have A is a 2 by 1. So you can see if you multiply now the matrix CA, okay, when you now interchange the order of the matrices appearance in terms of multiplication, when C starts then followed by A, we can see that this matrix is compatible because you have a what? 2 and you have a 2. All together. So then the resulting matrix will be a 2 by what? A 2 by 1. That is to say, when you multiply a matrix AB, it is not the same as multiplying a matrix BA. So when you interchange, or let me put it clearly here, from the example that we have just used, that AC is not the same as CA. So there's a way you can interchange your matrices and the resulting or the outcome are not the same. In fact, when you have a matrix A and you have another matrix C, even if they are compatible and you change the order and you change the positioning. Here we started with A then C, and this one you have C then A, then you shall find out that the two matrices outcome are not the same. So we can check a few examples on this and see how multiplication is basically done. Example, this is an example. So given A is 4, -2, 3, 4, and B is given by, so let me have it correctly. B is given by -1, 0, 2, -3. So I've chosen to just mix up the numbers, yeah, so that I can really get it well. Now, so determine 1 AB and 2 BA. So we have that. So therefore we can check the solution. So let me write it here. So the solution. Now, when it comes to multiplication, we said again you multiply the row and the what and the column. So we can have AB. Which is 4, -2, 3, 4. Then we have B is -1, 0, 2, negative what? Negative of 3. So we are multiplying the row multiplied by the column. So the first row multiplies with the first column, then the second. Then as you add the what? As you add the numbers. So we shall have, so 4 times -1 gives you -4. Now again I'll also encourage, now not one thing, When you multiply a negative number times a positive, it gives you a negative, okay? And since at the middle of them we have a positive, remember, since at the middle we have a positive number, when you just multiply a negative and a positive and multiply with another positive, it remains to be what? It remains to be negative by the end of the day. So what we can do is just basically multiply the numbers as you write them, okay? So for example here, 4 times negative 1 is negative 4. Negative 2 times 2 is negative 4. Are we together? Remember, we're supposed to have plus, then the multiplication of this. So it will be positive negative 4. But since it is a positive, it really doesn't change the outcome of the multiplication of the two numbers. Are we together? So just multiply. So this and this, multiply this and this, which gives us negative 4. Then again, the second column, 4 times 0, 0. Negative 2, negative 3, that becomes positive 6. Right, together. Then again, we come to the second row. 3 times negative 1, negative 3. 4 times 2 gives us 8. Then 3 times 0, 0. 4 times negative 3 gives us negative 12. Okay, now we can add them. Negative 4, that gives us negative 8. 0 plus 6 gives us 6. Negative 3 plus 8 gives us 5. 0 minus 12 gives us negative 12. And that is the outcome of A multiplied by what? Multiplied by B. Now let's come to BA. So our B is negative 1, 0, 2, negative 3. Then multiply by A is 4, negative 2. Then you have 3 what? 3, 4. Again, multiply the row and the column, the row and the column. So negative 1 times 4 gives us negative 4. 0 times 3. So you can see the first and the first, the second and the second. So negative 1, 4 gives us negative 4. 0 times 3 gives us plus what? Plus 0. Then we come negative 1, negative 2, that gives us a positive of 2. Then 0 times 4 gives us what? Gives us 0. Then we come to the second row and also the other two columns. 2 times 4 gives us 8. Negative 3, negative 3 and 3 gives us negative 9 altogether. Then you have 2 and negative 2, again negative 4. Negative 3 times 4 gives us negative of what? Negative of 12. So when I get the 2, so negative 4 plus 0 gives us negative 4. 2 plus 0 gives me 2. 8 minus 9 gives us negative 1. Then negative 4 minus 12 gives me negative of what? Negative of 16. So these are the outcomes for A times B and B times A. And you can see therefore, as we had said earlier, that AB will not be the same as BA. And from these outcomes, then we cannot testify that AB is not the same as BA. Though the two of them are compatible, they can be multiplied together. But the outcome is not the same. So when it comes to operation of matrices, addition, subtraction, and scalar multiplication, and also multiplication itself, then we say this is just the way to go about it. So with that, we're going to check some few things now. We're going to check how to transpose a matrix. Then we shall find the inner determinant. From the determinant, we shall find something called the inverse. Then from the inverse, we are going to solve simultaneous equation. So kindly again, as we continue the lesson, kindly remember to subscribe, share, and also comment how these lessons are helpful for you. Share between your friends also that we may benefit together in this